Hey guys, welcome. Today is going to be an interesting video because we are going to be doing a video within a video, which is kind of wild because I get to basically give commentary on a video already produced by somebody else, which is wild. Anyways, so we're going to listen to this girl talk about what a function. Hopefully a lot of this sounds familiar to you. We talked about a lot of it. So let's go ahead and get started. I'm going to add some things as we go, so let's go ahead and listen in. Oh, by the way, everything she writes down, you need to write down, okay? And if I add to it, you have to add to it, too.
What is a function? In order to define a function, let's start out by asking ourselves, what is a function? Really? What is it? Well, in order to figure out what a function is, let's take a look at a real-world example. Let's say that you're at an amusement park, and you put a penny into one of those souvenir penny machines. So let's write out how that would look. You would start off with a penny, and you would take that penny and put it into the machine. So we take the penny and put it into the machine. When we do, all this neat stuff happens inside the machine. And when it's done, the machine spits out a flattened penny, and it has something cool written on it, your souvenir. This is actually an example of a function. Here, our original penny that we start with is called our input. We take that penny and input it into the machine. Here, this machine performs an operation. Or we can also call this step our function. So we take our input and input it into the function. Then all this stuff happens, and when we're done, the result is this flattened penny, our souvenir, or our output. So this is an example of a function.
All right. So we talked about this before. Remember, bread goes into a toaster, out comes toast. That's a function. Same thing comes out every single time. What we want to add to it in our writing is an input has another name. It's not just an input. It's also known as an independent. If I can write, here we go. Let's see. She's a lot better at writing than me, apparently. My pen's not working. Here we go. It's out of ink. My independent and my output is my dependent. And this is very true. Think about it. The independent variable, independent means it lives on its own, it does its own thing, right? Okay, you don't rely on anybody, you don't have anyone to make your lunch, you don't have anyone to buy your clothes, feed you, anything like that. You're totally independent. And all of you guys are becoming more and more independent as you get older, okay? Most of you are, though, dependent upon people, right? You get to school because someone drives you there, so you depend upon them. You know, everything that you own is usually bought by somebody else because you guys don't have a job. Your job right now is to learn. So an independent and dependent is another word for input and output. The penny is independent. It doesn't have to go in the machine, okay? But the output only exists because of the penny. So the output, that flattened penny, is dependent upon you putting in the original penny in the first place. Let's keep going. She's doing great. Okay.
Now we can also write a function in math terms. Let's see that example. Instead of a penny as the input, let's have x equals 2. So our input value will be 2. We want to take that input value of 2 and input it into a function. Here, we'll have f of x equals x plus 3. This is an example of a function. Here, we would take that input value of 2 and write it in place of x in this function. So instead of x plus 3, we'll have 2 plus 3. Then we add. 2 plus 3 is 5. So our result is 5. That resulting number is our output. So now we have some examples of functions. So now that we have an idea about what a function is, let's take a look at the definition of a function.
Okay, I'm going to pause here real quick. Great job there. Look at that function notation, f of x. We've talked about that before. We have our independent variable x. What comes out depends upon what I put in. The 5 came out. It depended upon us putting a 2 in. If I didn't put a 2 in, I wouldn't get the 5. Continuing on. Awesome job. I don't know her name. Let's call her Laura. Take it away,
A
Laura.
function assigns each input value exactly one output value. If we take all of the input values for a function, all of those input values make up the domain of our function. And if we take all of the output values for a function, all of those output values make up the range of our function. Now, there are many ways to represent a function. One of these ways is by using a mapping diagram. So let's take a look at using a mapping diagram to represent a function. Let's see. Let's put the numbers 7, 4, 3, and -1. Then let's also have 2, 0, and 5. Here, the values on the left will be our input values, so they make up the domain. And we'll have these values on the right be the output values, so they will make up our range. Now, in order to be a function, each input value needs to be assigned exactly one output value.
Okay, for every x, there's only one y. Okay, we've talked about this before. For every input, there's only one output. For every domain piece, there's one range piece. For every independent variable, there's only one dependent variable. Okay, see how we have all these different names for almost the same thing? X can be called independent variable, the input, the domain. Y can be called the dependent variable, the output, the range. Take it away, Laura. You're crushing it.
So let's do that. We'll take the input value of 7 and assign it the output value of 0. Then we'll take the input value of 4 and assign it the output value of 2. Then we can take the input value of 3 and assign it the output value of 5. And we'll take -1 and assign it the output value of 5 as well. This is an example of a function. Notice, each input value only has one arrow going from it. That means that each input value has been assigned exactly one output value. And notice, the output value of 5 has been assigned multiple input values. Well, that's okay. Here we're just concerned with those input values. 3 has been assigned the output value of 5, and -1 has been assigned the output value of 5. Each of those input values has been assigned exactly one output value. So here we have an example of a function. Now let's take a look at another mapping diagram. For this one, let's not make a function so that we can see the difference. So here, let's make 3, -2, and 4 be our input values, and 6, 1, and 8 be our output values. Now, let's take 3 and assign it the output value of 1. Then we'll take -2 and assign it the output value of 6. But let's also assign it the output value of 8. Then we'll assign 4 the output value of 1. And now look at what we've done. The input value of -2 has 2 arrows going from it. That means it's been assigned 2 output values, 6 or 8. And in a function, we cannot have that. So here, this is a mapping diagram that does not represent a function. Now, in addition to mapping diagrams, we can represent functions a few different ways.
Let's pause here for a second here. You guys are doing awesome. We have function, no function. Make sure you're writing everything down that you see here. Laura's just crashing. We're just going to let her cruise. Look at, we only got 3 minutes.
So, let's take a look at the different ways that we can represent functions. We can represent functions as function rules. In fact, in this example, we had a function rule. We had f of x equals x plus 3. Function rules give us specific directions for how to change the input value to get the output value. Here, we can replace x with a number, say 2, the input value. Then we perform the operation taking 2 plus 3, and we get 5, the output value. Now, we can also represent functions as a set of ordered pairs. So, let's take a look at a set of ordered pairs that represents a function. Here, we open up our set and write the ordered pairs. We have 7, 0, 4, 2, 3, 5, and -1, 5. This set of ordered pairs represents a function. The first value in each of the ordered pairs is an input value for the function, and the second value in each of the ordered pairs is an output value. Now, in addition to ordered pairs, we can also represent a function as a table. If we have a table, we will have a list of input and output values. Here, x represents the input value, and f of x, or sometimes y, represents the output value. Here, we can pick one of the input values to be 1, and assign it the output value of 4. Then we can have an input value of 2, and assign it the output value of 5. And we can have 3 and 6, and 4 and 7. Now we can also create tables if we have a rule. In order to do that, we pick values for x and apply the rule in order to get these output values. And if we want, we can represent a function visually. To do that, we would graph the function. So we would take ordered.
All right, hold up. What is this? Get out of here. Stop. I don't know why that's there. Anyways, she said 3 examples. This is her 4th example. Was she crazy? She's crazy.
Pairs and plot them on a coordinate plane.
You can't do this, though. This is crazy.
Here is an example of a graph of a function.
Yep, that's a good function.
When we plot those ordered pairs, the x values, or the input values, are the horizontal location. And the y values, or the output values, are the vertical location on the coordinate plane. So now we know a little bit more about functions. A function assigns each input value exactly 1 output value.
Way to go, guys. That was Inception. Video within a video. I hope I blew your mind. I hope that was a lot of review, but I thought it was good to get a little bit of review, threw in a couple things, independent, dependent. We'll talk to you guys later, and ciao, main.